In this discussion of our special right triangles, we're going to be focusing on our 45, 45, 90 degree triangle. So again, these are referring to the angle measurements. What's important with the 45, 45, 90 degree triangle is that this is actually creating an isosceles triangle. Our two legs are congruent, so therefore it's isosceles. So when we have this, we don't have a short and long leg like we did with our 30, 60, 90. We just have our leg. They're both congruent to each other. And then we still have our hypotenuse. Again, we can take this and relate it to Pythagorean theorem. So taking this step out, if I have a triangle that is a right triangle that is isosceles, and let's say that our side length is 1 for the leg, that means our other side length is also going to be 1. And if I wanted to find out what our hypotenuse is, I can do Pythagorean theorem. 1 squared plus 1 squared equals x squared. And then again, remember to solve for x squared, I'm going to take the square root of both sides, and I'm not going to give an approximate answer. I'm going to give an exact answer and have the square root of 2. So when our legs are a side length of, in our case, n, our hypotenuse is going to be that side length. So there's this 1 here, 1 times radical 2. So the ratio for a 45, 45 degree triangle is n radical 2. So again, I can think of this as our table. It's 45, 45, 90, n to n radical 2. So let's take this and apply it. Well, actually, before we get that to there, I just want to remind you, our hypotenuse is the leg times radical 2. Okay? All right, so let's go ahead and apply this and look at some problems. So I'm going to draw a couple of triangles here. They're going to be 45 degrees, so we should know that they're isosceles. One leg is length of 20, one is x, and one is going to be y. So I need to solve for my variables, and so I need to find the lengths of x and y. So I'm going to make my table. 45, 45, 90, n radical 2. Always remind yourself of that. Okay? So since this is isosceles, I know that these two are both going to be the same. So in this case, my 20, I'll just put in the first one. So then that means I have x, and then I have y as my hypotenuse. So since n is equal to 20 and both sides are congruent to each other, that means, or both legs, that means x is equal to 20. And then since the hypotenuse is the leg times radical 2, that means that y is equal to the leg, which is 20, times radical 2. Let's do a second example. So I have a 45, 45, 90 degree triangle. I have a leg of length y, x, and a hypotenuse of 8 radical 2. So again, I'll start, make a table, my tic-tac-toe, 45, 45, 90. I have a n radical 2, because those are our ratio between the sides. Across from my 45, I've got y. Across from my other leg is my x. And then my hypotenuse is my 8 radical 2. So in this situation, we're saying that n radical 2 is equal to 8 radical 2. So I need to get down to n. So since this says n times radical 2, I'm going to go ahead and divide by that radical. So then I get that n is equal to 8. Those will cancel out. Okay, so if n is equal to 8, which I shouldn't have boxed that, so ignore that that's boxed up. All that's going to do is help me here, because if n is 8, kind of throwing this guy back over here, that means y is going to equal 8, and that means x is also going to be 8. All right, let's kick this up a notch. Example 3, we're going to have side lengths of x, y, and 6. Now, for the 45, 45, 90, you don't always have to see that it is 45 degrees. Obviously, that's very helpful. But if these two sides are the same, that's also going to imply and mean that this is also, it is isosceles, and the only way for that to happen with our 90 degree is that those will then become 45 degrees. Okay, so what do we start with? Our table, 45, 45, 90, n root 2. Okay, I'm going to fill in with my side lengths. I have a side length of y. I have a side length of x. I have a hypotenuse that is 6. So this started out very similar to our previous example, but now when I look at here, I'm seeing that n times radical 2 is equal to 6. I need to get down to n, still the same process, divide by, and I get that n is equal to 6 divided by root 2. Now remember, this is an acceptable answer, but this is not our preferred answer. So remember to rationalize that. I would be multiplying by root 2 over 2, which leads me to 6 root 2 over root 4, which I should know that this is just 2. So 6 root 2 over 2. And then I should be able to remember to reduce here. So equivalent answer for 6 divided by radical 2 is 3 times the square root of 2. Now what was that? That is what is the value of n. I didn't want n, I want to know what y is. Well, those are n is equal to y, so just remember y is equal to 3 root 2. And since it's isosceles, that means that x is equal to 3 root 2. Hopefully you have a better understanding of 45, 45, 90 degree triangles and make sure that you take a look at the practice problems provided. So again, just a reminder, 45, 45, 90, it's an isosceles triangle. The ratio of the sides opposite of those angles is n to n radical 2. And remember that the hypotenuse is the leg times radical 2.